FTC Alberta. Welcome to another piece of the Build Blitz. I know this one seems to drag on, but I sense that this season's going to have a lot of feel to that. It's Mitch Way, your senior mentor here, with a brand new haircut. I have to introduce myself again because people don't recognize me sans hair. It totally happens. Anyways, the purpose behind this video is actually very simple. The last one looked at how to unbox a kit, a few tips about how to put that together, maybe for some of our rookie teams. This actual lesson here is going to talk specifically about how to run your team from Fusion to real life. And the reason this video is taking so long to actually get up is this process is not fast. It's not something you're going to have done overnight. But the goal here is to take something in CAD, and I'm just going to hop over to my screen here in Fusion, and to take something like this. Now, I got the Studica kits. You saw me unboxing them, actually looking through some of the parts that they've got available, and I decided to put something like this together. Now, my goal was an X drive. I really shot high on this one. We'll do another video here at some point in the next few days about a little more basic drive, something that a rookie team could do, but perhaps you're more of a, more of an established team who might look at something like this. Now, the goal was to create this thing in Fusion, turn it into some sort of blueprint that could be communicated to a team member, passed along with the kit, and have them actually do the build, have them actually put this thing together, which is really what we were going for. And to a degree, we've succeeded. I'm just going to hop my screen to full size. Actual CAD, and I'm going to post the CAD of me building this start to finish somewhere at the end of this video, just at 8x speed, so everybody can watch. If you want to actually work on pieces of this and actually build something similar, be my guest. The purpose of this, though, was never to actually do the X drive per se. It was to figure out how we could communicate this design strategy to my build team. Now, my build team's a couple of my students who I passed this off to, and they actually did the build itself based off of some blueprints. And those blueprints are actually right here. You can see we printed these on some nice large paper to make an actual, basically a drawing of what we could do. Now I'm going to show you those blueprints in PDF form so you can see them nicely on the screen here. And then I'm going to show you how to make those blueprints, because that's really what this is all about, is the ability to take your CAD model that you built as the design team and take it to your team in a form that they can use. So without further ado, here's a picture of the actual drawings themselves, and we actually had 4 different drawings. So I started off with a basic, I'm just going to close down my browser here so you can see it all. Started off here with a very basic X drive drawing, okay? And this simply showed where all the parts were going to go. Now you'll notice that some of the parts, such as the rev hubs and those pieces, didn't actually get put on. I'll explain that in a minute, because that's part of your design process as well. Okay, we can see one here. This is actually just the structural component, just the superstructure, and I figured that our students would actually need that piece because they need to assemble this first, and the wheels tend to, if you look at the wheels here, they tend to obstruct the view on a lot of things. As well, I gave them a top-down view so you could kind of see how everything lined up. This turned out to be rather important, so they knew which pieces went where. And finally, I gave them a piece that was kind of the first steps. It was just the drive rails themselves, minus any of the attaching bits. And again, this proved to be important. Now, you'll notice that when I got these drawings back, I actually got these back with a whole bunch of comments on them. You can see that they've actually scratched a bunch of comments on here because we learned a couple things about this design in the course of building it. And this is where often this piece of engineering goes. I, as the designer, go design something. The build team or prototyping team or testing team actually goes out and tries it out, sends it back to me and realizes, hey, some of the stuff didn't work. Now, the things that didn't work in this drivetrain specifically, if we look at this piece of this flat right here, this was actually in my CAD library for these particular parts, but we didn't actually have that part. So in my notes, they've actually written on the drawing that they replaced this with a longer version. I believe it's a 192 if I remember correctly, to go the whole way across the robot. Also, they realized that we didn't have enough of these angle brackets, the 135-degree angle pieces, to attach the rev hubs. And they basically notarized that, hey, in your design, you're going to have to get rid of those. You're going to have to find some other way to do it, or we're going to have to order more parts, because we all know that happens in a build. Now let's talk about how to make these drawings. I've actually got my X drive open here, and this is kind of your first step. Open up your CAD model and whatever it happens to be. From here, you're actually going to go up to your File menu, and you're going to pull down New Drawing, and New Drawing from Design. Now, in this case, I actually put something together that was on nice A2 paper, something that's a little bit bigger. If you feel like you want to do this in inches to find out what your paper is, oh, hey, it's going to keep it in millimeters. We could change your document settings. Anyways, regardless, let's go for design. Let's move the thing up to A2, and let's work with that. Okay, we're going to create this from the full assembly. We could make pieces of this invisible before we make our drawing if we want. That sometimes can be helpful, but I'm actually going to show you how to do that in the drawing, which sometimes can be even more useful. We're going to create a brand new drawing, and we're going to go from there. It's going to tell us that some of our bodies and things won't quite show up properly. That's okay. We brought these over from step files, so that's inevitable. It's going to happen. Now, I'm going to be filling air in a couple places here, and what I mean by that is I'm going to actually be trying to talk over some time that my computer spends loading, because this step actually can take a little bit of time. Now, once I've gotten here, you'll notice that I've got a base view of my robot from the side view floating around here, and I've got a drawing view window, and this is what I really want to focus on right now. Because right now, on this piece of paper, the scale is not great. You can see that this robot takes up hardly any of the page. In this case, I wanted to use as many pages as I could. I like using more paper space when trying to communicate, because if I'm the build team, I want as many pictures, as many drawings, as many options as I can for my drawing. So I'm going to use more pages, and we'll show how to do that in a second. So I'm actually going to cut my scale down to 1 to 2. I might even go 1 to 1.5 here. What do we think? That's not bad. Now, let's take here, right now, this view is talking about a few different things, but specifically it's saying its orientation is front. Usually for my first drawing or my first design, I like to do it isometric, and there's some options here like southeast. This will show the bottom of the robot, or southwest, sorry, or northwest. And in this particular design, I really like the northwest view. I might even make this 1 to 1. This paper is actually large enough because this robot was actually approximately that size. So let's press here, left click, right click, and that's going to bring up your menu for what you want to do. I'm just going to press OK. Now, in this case, it's going to take a second to load, and this is where we're actually going to put the main drawing of our robot together. Now, there's a few other options here, but you'll notice that some of the details on this, like the file's name, okay, sheet number, and my name as the designer, they've all been actually ported automatically onto this piece of paper so that I can get my drawing of what I want. Now, this is obviously a really good overview of the robot so that my team can start looking at this, and I would actually start here. Now, the next thing I'm going to do, because I kind of like this as a first page, a few other things I sometimes do on this is I sometimes throw on some text here to describe things. One of my most common texts, and you'll see I did this here, I actually created a public link for Fusion 360. Now, if anybody's done a public link before, once you go to your actual drawing, this is a really good way to share designs amongst your team. Right-click on your design and go to Share Public Link. And when you do this, you're going to get a little window, and you're going to have to check off this box that's right here that says share the latest link. I'm going to grab the link here. Okay, I'm actually just going to copy it with this button here, and I'm quickly going to jump over to a Google Chrome window here and just plug that into Chrome. Now, when you do this, you can send that link to all of your team members, and it's so easy because this will open in Chrome, this will open on your phone, this will open on any device you want, and it'll actually show the 3D view, and even better, the exploded view of this. So let's talk about what that actual public view does. Now you notice that I've got access to the full drawing. It's in 3D. It's in a very scaled down CAD program in my browser. Fantastic. Again, this works on your phone. So if you want to send this design to somebody else on your build team and say, hey, what do you think of this? This is a great way to share those designs. Now, I got a few options, and I've used this. Any of you who are part of the CAD challenges in the spring know that sometimes we use these to actually measure things to say, hey, your robot's more than 18 inches long. That's no good. In this case, you're probably going to find, if I measured this right, that this robot, all told, side to side, is a little less than 15 inches across. I'm just going to grab rev hub to rev hub, but you can see we've got 279 millimeters, and I believe that is far, far less than our inches. Here we go. Let's turn this to inches. Fractional inches. There we go, about 11 inches across. So this is actually a really small robot, all told, for FTC, but we tested it in the sizing tool today. It definitely fits with some space to spare, so we can add some stuff to it. I digress. One of the cool pieces about this, as you're sending it and communicating with your team, this is actually not a bad view if your build team has access to a computer right there as they're building, because they can actually use the explode menu to actually pull apart pieces of this design. Now you'll notice that in this case, the rev hubs also are subsystems here, and they will actually start to get pulled apart as well. Your motors may be in the same boat, so if you have tornadoes that you didn't plan on disassembling, well, they might look that way. But what you can see here is that you can see where all of the pieces are actually going to go. And if I, as a build team member, want to just follow how these pieces go together, I can absolutely do that. And you'll notice that when we were attaching these, that was one of the other notes we got. We actually had no really good way of attaching multiple layers of these pieces together. This part here specifically had to be 3 layers, and it just didn't work. We didn't have the right bolts for it. That communication is key. And it's possible as well, if your team wants to, they could actually turn around and use the markup menu here. And this is going to allow them to actually say here, okay, At that point, I had too many layers for 12mm bolts. Need to order longer. Okay, that's an example of something that your build team might throw on here, and then they can simply go from here, save a snapshot of it, and this will download itself as a ping file, and then you just send it to them and say, hey, I got a snapshot of this with some notes on it, with some stuff that's gone wrong. We got line tools, we have freehand, lots of options here. Anyways, I digress. This is a really good way of communicating, but the easiest way often is to create these drawings. So we're going to go back to our drawings. Now I'm going to save my drawings. I'm going to tell you to learn my lesson, because I actually made this full set of drawings once after many, many minutes of loading, and I actually had Fusion crash on me on my computer. It didn't save. It doesn't auto-save the drawings quite as well, especially if they're not named. So naming them, not a bad idea. I'm just going to call this drawing 2 because I already have a drawing number 1. Let's save this thing. Now, you notice in this particular drawing that I've actually got a browser over here. Now, this won't show up when I actually export this as a PDF, but what this is going to do is actually show me all the parts that are involved in this particular drawing. If I want one of them to go away, like let's say in this drawing, this control hub that's nearest to me is one that I probably want to disappear so that we can see the rest of the robot, I'm just going to scroll through here and find out where it is, and I can click the I button here and I can actually make it go away. I can actually just make it invisible for the sake of this drawing. You're going to see it's going to take a second to load, but there we go. There's my new drawing, sans that part that I didn't necessarily need. And this goes for all of the drawings too. I can keep drawing base views on this, and I can keep choosing what I want to do with them. So in this case, maybe I want a top view at a 1:1 scale. We just measured this and found out it's 11 inches across from side to side. So on this 11 by 17 paper, this might just fit, actually, oddly. Let's go see. Let's press OK, and let's see what we get. I think it'll just fit. Anyways, this is, again, that top-down view that you saw before. And again, if I decide for my top-down view that I maybe don't want my battery on here, maybe don't want to show the hub so people can just see the structural pieces, I can absolutely do that by just making things invisible over here. Okay, and in this case, I got pretty close. Okay, this drawing is just about the right size to do that. And again, like let's say I want to just show the superstructure. I go through here, and I take my rev hubs, I turn this off, and what you're going to see is those parts are just going to disappear from your drawing. You don't need to communicate those, because that's what this is right here. This is you communicating your designs from your design team to your build team, and this could potentially make it so that disparate parts of your team, let's say you have to go self-isolate at some point during this year. It's happening to students all across this province. Maybe you have to go self-isolate. You can still be a part of your robotics team even though you physically can't be in the room, and that's a big piece of this. Anyways, we got a top view. I'm going to show you one more cool view that I like, and I like it because I teach it in class, and I think it's super cool. We can actually do orthographic views of this too. So if we want to do a side view, and I'm just going to do this at a 1:2 scale, because I know that it's going to fit on this piece of paper, we can actually show all the elevations of this piece of work right here by pressing OK. And we're actually going to use the projection view here. I'm actually going to show you 2 more tools that may become handy for you as you go through. And we will talk about those. We're going to talk actually specifically about basically we could talk section views. We're going to talk detail view. All right, I'm just going to reduce my browser here to show that we've got the side of this robot. We do have an option here to do something in a projected view, and that's going to allow us to actually take this model and show an orthographic projection. This means that everything lines up at 90-degree angles, and we can see the top, and potentially we can see the side. Those are left clicks I just did, and then we also could show an isometric view down here. When I right click, I press OK, it's going to take a second to load, but it's going to drop all 3 of these views into this particular drawing. Those views are going to be linked back to this original drawing right here, so if I want to make any pieces invisible, I can do it on all 3. There's also a way to go in and do it on just one of them if that makes you particularly happy. But this is the way to actually design these things, because you can send these PDFs really easily and really lightly to your design or your build team, have them print them off and actually do their build based off of these with very little technology involved at that point. They then scratch them up, put all the notes on them as to what worked, what didn't, and send them back to you. And you might have to recad some of this stuff. It'll make you really good at the design piece of any robot build. And I'm just seeing if I'm lagging here. I think that might be the case. Now, again, the purpose behind this is to make sure that you have designs that you can send to your build team. The purpose behind this is to make sure that your team understands what's going on with the robot. It also looks really cool when it comes down to your engineering design journal. Here we go, we've got loading, that's good. I do want to change one more thing on this, because this drawing, this isometric view, I actually want to show specifically what the colors are, what the shading is, just in case there's any ambiguity left here. To do that, I'm going to double click on it, left click. I'm going to get this menu again, and this menu is actually going to give me some options. In some cases, I might actually want to do hidden lines, and if I do that, it's going to show every hidden line that's behind another line. In an FTC robot, that can get kind of messy. I really just want to do shaded view here. Now this is going to take a second, but what it's going to do is it's actually going to shade in the pieces of this robot to make it match the actual CAD model. If I've applied any appearances anywhere in here, that's a good place to look at them and see how they actually work. Now, with that being said, this is a really good way to communicate. I am going to pin at the end of this video a full CAD breakdown of how I did the X drive. And just so you know, for any rookie teams who are looking at something like this, the next video is going to talk about how to build a basic bot using the Studica, some of the Studica parts. All right, I think I got it. There we go. We have a nice color 3D model there, and then it's going to give us the visible edges, and it's going to color it in. Great way to communicate this, because if I'm a build team member and I see this series of drawings here, I have a very good chance of putting this together to the specifications that the design team wanted. This gets more people involved with your team and potentially could make a team run in the COVID era that otherwise may not. You may be in a place where you only have one person building and the rest of the team wants to be involved in the design. Maybe that person's going to build, someone else is going to program, someone else is going to drive. It's a good way to do it in some cases. Finally, when you're all said and done, you've got all your drawings put together here, you've hit save, you're going to go to output, and you're going to tell Fusion that you want to output either all sheets, current sheets, selected sheet, whatever you want. I like all sheets. At this point, it's going to go ahead and it's going to save your actual drawing as a PDF. And I'm just going to throw this on the desktop, and I checked off the button that said Open PDF. So as soon as it's ready, as soon as it's exported the actual drawings here, it's going to pop them up as a PDF, and I'll show you what they look like before you send them to your team, before you send them to your build team, before you print them off to show your mentors so they can score them up with a marker. We love doing that. That's fantastic for actually putting stuff together. Now let me throw this here. It's the only time here. Here we go. There we go. We have some nice PDF views of all of these parts of the robot that can be sent to the printer, run off, and sent to your design team. Easy as that. The last thing you may need, the last skill I'm going to go through before we're all done here, is you may need to put a detail view on something. Let's say I have a particular piece of this robot, and I think I do in this this third piece. Let's go with this. Actually, let's go with the second piece. I'm going to give a detail view specifically of this joint on the wheel. Now, nothing specific. You may have something like this in your robot that's somewhat small, but is really important. So in this case, I'm just going to open up this detail view by clicking once and dragging a circle out, and that circle is going to allow me to create section A, or detail A. It's going to label it, or should label it, and it's going to let me put this elsewhere on my drawing. And this I can left click, right click, and press OK, and what's going to happen is it's going to show that individual piece of detail specific to that. It's going to blow it up, and I can actually make the scale of this significantly higher. Like, let's say I want to actually make this at a 4:1 scale. I can actually blow this up so it takes up a significant portion of the page. In this case, I'm going to go 3:1, and I'm going to make it color in this case. And that's going to last. Emma, I'm recording. I'm recording. Thank you. You can say hello, though. Hello, Emma. Anyways, here's your detail view, and you can see that it shows up with the circle here as to where the detail is, and the letter A. That letter A can be moved if it's in an inopportune place, which ours is. And then we take our section view or detail view here, and this wouldn't pass my class and by any means, but we can actually see that because it overlaps here. But we can see that this is section A. It's at a 3:1 scale, whereas the rest of the thing is at a different scale here. That being said, this is a way to actually communicate things with your team. Without further ado, I'm going to show the full CAD at very fast speed here of the robot actually coming together in CAD, and hopefully we can get you a different drive base here in the next little bit, and maybe some shooting mechanisms to test out. Cheers!